Hey everyone, it's your name from ThinkSphere Global. Get ready for an awesome journey as we explore the cool science behind the sounds we hear every day. Have you ever thought about why a clock ticking has such a sharp sound? Or how about that cool pop when you snap your fingers? These aren't just random noises, guys. They're actually physics in action, hiding amazing secrets right in front of us. Let's jump into the world of everyday sounds, a place where physics plays its music all around us. If you want to uncover the mysteries of these familiar noises, hit that subscribe button and join our group of curious minds. Okay, let's start with something we've all done a million times, snapping our fingers. Seems pretty simple, right? But believe me, there's some serious science happening behind that cool snapping sound. You might think it's just your fingers hitting each other, but it's way cooler than that. It's actually the super fast release of squished air. When you snap, you're squeezing your finger against your thumb, building up pressure in that tiny space. Then bam, your finger slips past your thumb, letting out a burst of air that crashes into your palm. That crash creates a shock wave, and that's the sound of your snap. Scientists have actually filmed this with super fast cameras, and what they found is amazing. Those fingers move crazy fast. We're talking about the speed of a baseball pitcher's fastest throw. That's over 50 miles per hour of pure finger snapping power. So next time you snap your fingers, remember, you're not just making a sound, you're doing a mini science experiment. Okay, get ready for this one. Have you ever seen those videos where a singer hits a super high note and a wine glass explodes? It looks like magic, but it's really just science at work. This is called resonance, and it's all about vibrations. See, everything from a tiny tuning fork to a huge bridge has a natural speed at which it vibrates. It's like its own special hum, and when a sound wave with the same speed hits that object, things get crazy. Think of it like pushing someone on a swing. If you push at the right time, matching the swing's rhythm, they go higher and higher. That's resonance. The energy from your push makes the swing's natural movement bigger. Now back to that wine glass. When the singer hits the right note, the sound waves match the glass's natural speed. The glass starts shaking more and more until, bam, it can't handle the energy and breaks. It's a powerful reminder that sound isn't just something we hear. It's a force that can actually move things and sometimes even break them. Alright, let's get a little spooky. Imagine this. You're inside a giant dome like St. Paul's Cathedral in London. You whisper something to the wall, and someone on the other side of the dome hears you perfectly. Creepy, right? This is a real thing called the whispering gallery effect, and it's like something straight out of a spy movie. So, how does sound travel so far without disappearing? It's all about the shape of the dome. When you whisper, your sound waves spread out, but instead of fading away in the air, they hit the curved walls of the dome. And here's the cool part. The sound waves actually bend and travel along the wall, like a race car going around a curve. This means the sound waves can travel much farther than they normally would in the open air. It's like the dome is a giant sound tunnel, guiding your whisper all the way to the other side. The whispering gallery effect shows us how the shape of something can totally change how sound works. It's physics and architecture teaming up to create something truly amazing. Let's talk about birds for a minute. Ever wonder why birds on power lines don't get dizzy? They have incredible ears that help them stay balanced. Birds use sound to navigate and balance like built-in GPS. Next time you see a bird singing, remember, they're navigating their world. Okay, let's be real, this one's a little gross, but we've all got to admit, that cracking sound your knuckles make is strangely satisfying. But have you ever wondered what makes that popping sound? Well, get ready for this. It's all about bubbles. Our joints have a special liquid around them that helps them move smoothly, and when you stretch or bend your fingers, you're changing the pressure inside those joints. Now when the pressure drops really fast, tiny gas bubbles can form in that joint liquid. It's like opening a can of soda. Release the pressure and bubbles pop up. And just like those soda bubbles, when the pressure builds back up, those joint bubbles can collapse with a sharp snap. That's the sound you hear when you crack your knuckles, those tiny gas bubbles in your joint fluid collapsing quickly. It's a little weird when you think about it, but hey, that's the human body for you, always full of surprises. So there you have it, everyone. The next time you hear a snap, a pop, or a chirp, remember, it's not just a random noise, it's the awesome world of physics happening all around us. From the super fast air pressure of a finger snap, to the crazy vibrations that can break glass, everyday sounds are full of mind-blowing science. If you like this sound adventure, make sure to give this video a thumbs up and share it with your friends. Let's spread the love of science and the wonder of everyday sounds. And don't forget to subscribe and hit that bell icon so you don't miss out on our next awesome adventure. Thanks for watching, and until next time, keep those ears open and those minds curious.